Alrighty, welcome to this little video lesson because I'm not going to be here for today's lesson. So what I actually want you to do is to try the warm-up before you keep watching. So if you could actually just pause the video, try the warm-up, see if you can figure it out on your own before I go and give the answer. Now, I could just sit here and wait for you, but that'd be kind of awkward, don't you think? So I'm just going to keep going as though you have actually paused this thing. So if we're looking at this, a function y equals f of x with a given domain, we're going to solve the inequality for whenever f of x is bigger than 0. So it's asking us when is y positive. So y is positive, if I can get this thing to actually draw. Here we go. Y is positive there, there, and then up till there. So what this is really asking for is for us to list the x values where y is greater than 0. So it actually equals 0 at -4, -2, 0, 2, and 4. So I don't want to include those because this right here is just greater than 0. So I'm going to say from -4 to -2, and then from 0 to 2, and then from 4 to 5. But this one right here is included, because that's this point right here, which is included, and the y values are bigger than 0 there. So that's what we're going to be going over today, basically, is solving polynomial inequalities. So basically, when is the y value greater than 0? When is the y value less than 0? We have a couple other ones that we could do. So if I figure out how to scroll on this thing, there we go. So we can have greater than 0, greater than or equal to 0, less than 0, less than or equal to 0. We could have just not equal to 0. So this is basically the exact opposite of everything we've been doing, which is finding when does f of x actually equal 0. So if I'm looking at this first question here, okay, so it says, if we want to solve for when f of x is greater than 0, we just have to find all the values that make it positive. So if we're looking at this graph over here, let me switch to a highlighter. I have, that was not the color I thought it was going to be. Whew. I have this part right here, pretend like that actually curved. That's when this is greater than 0. Okay, so that's going to be from -infinity all the way up till -2. Okay, but it's not or equal to again, so I'm going to exclude 2, and then I'm going to pick it back up at +2 all the way up till positive infinity. Now we get a little bit tricky here. So it says if we are greater than or equal to 0, I actually need to include that point as well as -2 and +2. So there's a couple different ways we could do that. This is the way that I'm going to suggest we do it. Let's put a square bracket like that, and then I need to include this -1 here. So you could say like -1 like that, but that's not typically how we do it. We actually would do something that was like a curlicue bracket, -1, curlicue bracket, and then we'd pick it back up from 2 to infinity. Okay, and I need to include this and these guys right here because I'm actually including 0, so I need to actually include the zeros. So if I continue, now we'll do when it's less than 0, so let me highlight that part for us here. So we got this little part, which apparently it always wants to draw straight lines for me, so hopefully you figured out that that's what I'm trying to highlight. And let's see, so when we're less than 0, right, that's going to be from -2 to -1, but we can't include -1 because it's actually 0 there. So we have to kind of exclude -1, pick it back up all the way up until +2. Now, if we want to include 0, we actually don't need this break anymore because we're actually going to be able to equal -1 and we can equal -2. So I have a bracket, -2, all the way up till +2 bracket, because this time I can include -1 because -1 is a 0. If we want to do this last one down here, so we want to figure out when is it just not equal to 0. So we basically just exclude all the zeros. So if the zeros are at -2, -1, and 2, I'm just going to exclude those. So I'm going to go -infinity to -2, excluding -2, up to -1, exclude -1, up to 2, almost messed up, 2, 2, infinity, and now we have when f of x does not equal 0. So, questions so far? I don't know. I can't get feedback from you yet, so I don't know. Write questions down on the side and we'll go over them tomorrow. So now we have this thing where we don't have a graph. It's a little bit trickier when you don't have a graph because you visually can't see when it's greater than or less than 0 for the y values. So what we end up doing is kind of following these 5 steps over here. So we basically set the inequality equal to 0, we factor it. Then we're going to set each factor equal to 0 and solve to determine what we call these critical points. Okay? And then we're going to plot those on a number line, and we're going to use multiplicities to determine signs. So that's a bunch of gibberish. So I'm going to jump back over here and actually go back down to this one, if I can get it to go down. And I'm going to draw exactly what it said based on this graph. So I essentially have a number line. My critical points are these zeros. Okay, so if I'm looking at this, -2 has an odd multiplicity, -1 has an even multiplicity, so I'm going to put a little m2 here. +2 has an odd multiplicity, it's probably an m3, but we don't really know that, we just know it's odd from the graph. And what I can do is make a little sign chart here and say, hey, when I'm up here, okay, which corresponds to this part, I'm positive. Then I have an odd multiplicity, so at -2, so I cross signs and I become negative. So that's this little part right here. And then because I'm even, I stay negative all the way until I hit 2, and then I switch to being positive again. So we actually could just use this little sign chart right here to answer our questions. If we can make this sign chart, we can figure out when is it positive and when is it negative. So let's jump back over here and let's figure that out for this one. So I'm going to draw a little sign chart. And I'm going to put some important numbers on it. So when this thing equals 0. So it equals 0 right here at -3. X squared plus 1 never equals 0. So remember that one gives us imaginary things, so we don't want that. So we're just going to ignore it. And then I have 1 over here at 4 with an even multiplicity. That was a weird looking 4. My board stopped working for a second. So all I need to do is just figure out where is it positive and when is it negative for just one part. So either less than -3, between -3 and 4, or greater than 4. Because if I can figure out where it is in one spot, I can use multiplicities to tell me whether it stays the same sign or whether it switches. So I'm going to choose to pick a point, which I'm going to use 0. Okay, so it's not actually on my sign chart, so I don't want to actually officially put it there. I tried to make a dash and it failed miserably. I hope this is as much fun for you as it is for me. So let's see. I'm going to plug 0 into this entire equation and see what I get. So I'm going to get 3 times 1 times -4 squared. Now, I don't actually care what the number is. All I care about is whether it's positive or negative. So this negative squared is going to become positive. Everything else is positive, which means I'm positive when I'm at 0. And it can't change signs until it hits the -3 or the 4 potentially. So let's go towards the -3. It's an odd multiplicity, so I'm going to change signs. So I'm going to go from positive to negative. At +4, it's an even multiplicity, so I'm going to stay the same side. Okay, so I'm going to be at positive there. So if I were to just super roughly sketch out what I thought this graph might look like, apparently I have a blue marker now, I'm going to go from negative to positive at -3, and then at 4 I'm going to bounce. And this is roughly speaking what this graph might look like. Okay? So when I'm less than -3, I'm negative. Once I hit -3, right there, I turn positive and I stay positive for the rest of the graph. So now we can actually answer kind of all of these different intervals that we want to. So they're asking us for 3 in particular here, and I'm just going to list pretty much every possible combination we could have. Okay, so let me just scroll a little bit here, and I need a skinny marker. So I'm going to do f of x equals 0. I'm going to do f of x is greater than 0. F of x is greater than or equal to 0. f of x, I should have just made a table for you. It's less than 0. F of x is less than or equal to 0. Whew. And the last one is f of x is just not equal to 0. So I'm going to use my little sign chart up here to help me answer this. So it equals 0 at -3 and 4. So I would just write that as x equals -3 and 4 with a multiplicity of 2. Remember, we should always list the multiplicities. This one is saying, when is f of x greater than 0? So that's asking, when is this thing positive? So it's positive between -3 and 4, and then from 4 to infinity. And we have to exclude 4 because it's not or equal to. So I'm going to go from -3 to 4, and then from 4 to infinity. When I equal 0 for the next one, okay, so I'm going to start off with a bracket around -3. I don't need to take this little pit stop at 4. I can just continue all the way up to infinity because I'm allowed to equal 0 now. When we go to do the less ones, it's -infinity up till -3. It'll be that same interval when we're or equal to 0, except that -3 is going to be included, and I need to include 4, so I'm going to do the little curly Q bracket. I don't care if you do square bracket 4, if that's easier for you to remember. And the last one is basically a combo of these. I'm just going to do the exact opposite of this one. So I'm going to say from -infinity to -3, from -3 to 4, and from 4 to infinity. So, I don't know. How you doing so far? Rocket science? Not rocket science? I don't know. This one's going to be really tricky for me to do right now because I don't have a graphing calculator on the computer I'm using. So, but I'll set it up for you and I can draw a pretty picture, and I need to remember to set my default back to being white on the bottom here. But basically what we're going to do is, the easiest way is to set this inequality equal to 0. So I'm going to actually add the 8x and subtract the 2. So I have this now. And I'm going to graph just the first part. I'm going to put this in y1, and I'm just going to graph it. So if we do that, I'm going to draw the pretty picture. You should be graphing this in your calculator. I'm going to attempt to draw this somewhat like what it really looks like. So I think it goes, oh boy, that was rough. Let's think here. Let me try to add some little tick marks in so I can actually get this. I think it crosses at -2 right there. It crosses somewhere in between 0 and 1, and somewhere in between 1 and 2, and then somewhere in between, I think, 4 and 5. Yeah. So what we need to do is figure out what are these zeros, basically. And then we're looking for when is this thing less than 0. So we're looking for when is it negative. So it's going to be negative from -infinity all the way up until this first 0 right here. So using the calculator, I just do second trace 0 and search for that one. I'm going to get about 0.32. Okay, and since I'm allowed to equal 0, I'm going to include it. And then I'm going to do second trace 0 to find this one, which is about 1.46, I think. And then I'll do second calc 0 to find that one, which was 4.21. Okay, and I know there can't be any other zeros because it's an x to the third. And so I got all 3 zeros, and this is whenever it is below the axis. So from this part right here, -infinity to 0.32, and then from 1.46 to 4.21, I am less than 0. That was supposed to be an arrow. I don't know. It got messed up. I hope you're doing okay so far. We got one more example, and then we're done. So this one. Whew. So we're going to try to do it analytically, so that means without the calculator. And what that means is I basically need to try to factor this. Now, first guess would be to maybe try to factor by grouping, but I don't think that's going to work. I can pull an x squared out of the first one, which will give me a 2x minus 7. And for the next one, I can only pull out a 2, which is going to give me like a 5x. So that's not going to probably work. So we're going to jump back and kind of do this a little bit old school. We're going to say factors of 24 over factors of 2. and that's going to give me a big old list of a bunch of numbers. Okay, so I'm not going to write them all out, but I get plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, 8, 12, 24, 1/2, and 3/2. So like, a lot of them. And I could go through and test a lot of them, but what I'm going to do is probably just cheat a little bit. And I'm going to graph this super quick on my calculator just so I can kind of get a feel of what I think it looks like. So if I try to do that, it kind of looks like -2 and 4 are going to be some pretty solid choices for me to check. So I'm just going to use those in synthetic division to try to reduce this x to the third down. So I'm putting my -2 up in the corner, and I'm going to do 2, -7, -10, 24. Bring this down, I got 2, -4, -11. Math, so tricky sometimes. 12, -24, and we get a 0, so we did it right. So I'm going to put 4 and just continue. So that's going to give me 2, 8, what is this, -3, -12, and I get another 0. And so my last one right here, this is going to be an x equals a 3/2. So that's what this one is. So now that I have those, I actually want to rewrite this original thing in its factored form. So I want to do the linear factorization of it. So I'm going to have x plus 2, x minus 4, and then to make sure I have this leading coefficient, I'm going to do this one as 2x minus 3. Okay, so I'm turning this one into this 2x minus 3, and then that has to be greater than or equal to 0. So I'm just going to make my sign chart and put all my information on it that I can. So I'm going to put -2, I have a positive 1.5, so that's the 3/2 up there, and then I have a positive 4, and drop my marker. See, it's just like real class. And let's see, I need to figure out when I'm positive and when I'm negative. So I can actually use the y-intercept, which is positive. That happens in here. So I know I'm positive between -2 and 1.5 because when x is 0, the y-intercept is positive 24. And now I can just use multiplicities. All of these have a multiplicity of 1, so the sign's going to change each time. I'm going to go from positive to negative, from negative to positive, and then way over here I'm going to go back from positive backwards and go negative. So now I can just look at this. It's asking me when am I positive. So from -2 to 1.5, I don't want to actually equal 0, and from 4 to infinity. Ta-da! We're done. So I hope that you were able to figure this this stuff out. You can try obviously doing the homework. So it's 1, 2, 3, 4 are pretty basic. 5 and 6 are on the next page. 7 and 8 get a little bit tricky. You're going to want to use some of our optimation. I can't talk. Optimate. I don't know how to say it anymore. Whatever. You know what I'm trying to say. The stuff we learned in class the day before you're watching this video. And see if you can figure out those last two. It's 100% okay if you can't figure out 7 and 8 yet. We'll get to them eventually. Alright, so I hope this video wasn't too much torture for you, and I hope that you realized you could have listened to it at like 2 times the speed, and it would have taken you half as long. Alright, adios amigos.